Hello, everyone. My name is Jay Wheeler. I'm an undergraduate student from Davidson College. This summer, I worked with the Center for Computational Biology with Dr. Pearson Miller and also Mackie O'Hara from the University of Kent. Our project was focused on tooth development, specifically the process of amelogenesis. So, amelogenesis is the process of ameloblast cells secreting enamel onto the tooth surface. They do this by starting on one end of the or one side of the tooth and lay down a protein matrix which matures and hardens into enamel. Dental anthropologists and biologists do not have a lot of information on the specifics or details of this process. They have the general understanding of amelogenesis, but not necessarily how the individual parameters affect tooth shape. So that was our goal for the project. We wanted to model amelogenesis and see how these different characteristics and parameters affect how the tooth looks. So those parameters are Retzius periodicity, cuspal enamel thickness, enamel extension rate, and daily secretion rate. We are introducing a new parameter called ameloblast transition rate, and this is the rate at which the ameloblast cells stop producing enamel. Based on this, we can hypothesize that tooth geometry does not affect striae patterns. So those striae are called perikymata. They're horizontal striations on the tooth surface. They are present after the ameloblasts move on the tooth surface, so they can be seen as a time record of growth. And like I said, they're remnants of enamel deposition cycle within a period of 8 days. Okay, so for our tooth data, we used 12 teeth in total. 6 of them were incisors, which is this picture, and then the other 6 were premolars. And these were all from modern human day teeth as well. So our first step in our project was to make an accurate simulation that depicts the movement of the ameloblasts on the tooth surface. So to do the simulation, we used the tooth data that I just showed specifically for the incisors, but also for the premolars. And we had to do an image segmentation to get the outline shape of the tooth and find the boundaries and significant points of the tooth. And then we used data that our collaborator gave us. So those were the secretion rates, the extension rates, the periodicity, and put this into a model. And there's also some equations that help explain how these parameters work and how they affect tooth shape. So from that, we were able to create a model similar to this that shows the tooth shape. And yeah. So from this model, we were also able to do a perikymata count comparison. So on the x-axis, we have decile. The decile is how we break up the tooth into 10 sections just to make it easier to look at and study. On the y-axis, we have the perikymata, which are those horizontal features that are left on the tooth after the ameloblasts create the enamel. So from this graph, and this is using the 6 incisors, from this graph, even though there's a variation, you can see that there's quite a similar trend between all 6 teeth. And this helps to support our earlier hypothesis that tooth geometry does not determine how much striae is on the tooth, that for the most part, it's independent. Our next phase in the project was to see how individual parameters influence tooth geometry. So the parameters we focused on were enamel extension rate, the ameloblast transition rate, and EDJ length. So the right side of graphs are the decile versus perikymata. They're similar to the graph I showed before, so we're focusing more on the left side, which shows average enamel thickness on the x-axis and crown height on the y-axis. So this will show how thick and long the tooth will be. So the enamel extension rate, which is the very top graph, and the ameloblaст transition rate have a very interesting relationship because they are inverse. With the ameloblaст transition rate, which is in the middle, you can see that the longer your ameloblaст transition rate is, the bigger the tooth is, because it's taking a much longer time for the ameloblasts to stop producing enamel, leaving more time for the enamel to build up and to create a much thicker and longer tooth. This is opposite to the enamel extension rate, because the enamel extension rate is the rate at which the ameloblasts differentiate and also the rate at which the crown height grows. So as you can see, the crown height is mostly focused by, or mostly infected or influenced, sorry, by the enamel extension rate. So you have a much longer tooth, but the average enamel thickness is not as completely affected. Then lastly, at the bottom, we have the enamel-dentine junction. So your dentin is the supporting structure of your tooth. That's what your enamel is built on. So in a sense, this has to match how big or how wide your tooth is. So that's pretty self-explanatory. So from this, our results, we were able to create a data set and use image segmentation and the cell kinematic data like extension rates, secretion rates, and periodicity. We were able to accurately create a model that showed the cell trajectories of the ameloblasts. We were able to use this to make figures to see how the parameters affect the tooth shape and compare those parameters as well. So for conclusion and future work, like I said before, there's not a lot of information on how these parameters work individually. So this is the first attempt to quantitatively combine this data and make a realistic whole tooth model of amelogenesis. We would like to publish this and have the code be open source for the biologists and anthropologists to use in their fields. And this is also an introduction of the hypothesized ameloblast transition rate. So hopefully they can also use this to figure out how ameloblasts know when and where to stop producing enamel on the tooth. For upcoming analysis, we would like to build on this model to make it more accurate. So we will be using Bayesian analysis to take previous knowledge and keep making the model more accurate. And thank you for listening. I hope you learned a lot. And any questions?
All right, we'll start in the room. Any questions for Jay? Yeah, Jalen.
Hi, Jay. I wanted to ask if there was any significance in your decile versus Perikymata graph of the dip that is at decile 2.
Yeah, I can go back. How do you go back? That's not. Oh, there we go. So you're talking about this dip at decile 2 right here? Okay, so, and I can also show you another picture, but that's due because of the cusp of the tooth. So as you can see, wait, here's the pointer. Okay. Right here, how there's a lot fewer, they just sort of clump up together in some points and not in this point. So that's why you can see like there's a dip right there. But then as you go further, there's a lot more. You can see that there. So that's what, and that dip at around, like it just goes, decreases like that. So they tend to clump up in that one spot.
Other questions in the room? Yeah, Professor Gates.
Thank you for the presentation. This is sort of off the wall, but I'm known for asking off the wall questions. Obviously, enamel's very specialized, hard part of the body, but one begins to wonder about, for example, fingernails.
Mm.
Where the question are there similar kinds of studies about the way the fingernails grow? Because a lot of people like nice nails.
If Yeah, that's a very good question. I'm not too sure about if there are any studies. I'm sure there are, but I don't know about them. I'm also kind of curious if there's a relationship to how enamel and fingernails grow, but I personally did not study that. But that is a very good question.
Other questions in the room? Is any? Oh, yeah, Carlton.
For the presentation. With your like sample of teeth, do you know if they came from the same subject or different subjects?
I think they're all different subjects, but I think they're from the same area. I believe they're from the same area.
Okay, thank you.
All right, how about on Zoom? If anybody is on Zoom and has a question, you can unmute yourself and ask. All right, the awkward silence, we can end now. I actually have one question, and that is you looked at two different kinds of teeth, right?
Mm-hmm.
But like, I know nothing. How many kinds of teeth do we have? And would there be an extension to look at all the different types of teeth we have?
Yeah, that's a good question. So we have our incisors, canine, and I believe with premolar and molars. I guess that's about 4 different kinds of teeth. We just focus on incisors and premolar because that was the data we were given. But I'm sure in other studies that they also look at other teeth as well.
All right, great. Let's thank Jay again.
Thank you.